Good day, everybody. My name is Jay Garcia. I'm from Modus Create and I'm part of the React Native community. I've been using React Native since January 2015, so almost a year now. And one of the things that I've continuously had problems with is optimizing React Native applications. Performance seems to be something that I've spent a lot of my time focusing on when it comes to pushing to production. There are lots of challenges, including things like list view, a view which I love and also hate at the same time. It becomes a challenge to optimize your applications from that perspective. List view is definitely one of those challenging views. But also, when it comes to React Native and how it works, the business logic that you're generating is in JavaScript, which means it runs in the same thread that the animations library runs in. So if you're trying to inject a view or create a view animated at the same time while things like images are being rendered, what you start to see is frames being dropped. And everybody knows, who's a front-end developer, that when frames are dropped, the actual the user experience suffers significantly. So what I'm going to do is walk you through some of the techniques I used, which are freely available online. They are on the React Native docs website. I'll provide a link at the end of this video to so that everybody can leverage it. But the truth is that the stuff isn't very difficult. At least the tricks I used wasn't very difficult at all. But before we actually get into the technical stuff, I kind of want to walk everybody through what it was like and the techniques I used to render the video, or at least capture it. So on the December 23rd, 2015 is when I recorded the video initially of the side-by-side. If you look at the screen, you'll see a screen capture of the YouTube video. And when I recorded this video, I had to do it in a couple of passes. And in order to record the video, I had to leverage the iOS lightning cable and plug it into my iPhone. And I'll show you how that works in a bit. But the reality is that the technique I'm leveraging to record the video only allows me to capture about 30 frames per second. It is how it works with QuickTime. I wish I had at the moment another iPhone 6 perhaps, so that I could actually do from the camera perspective, do a 60 frames per second recording. It would allow us to see things in much finer detail. But that wasn't the case. So I'm going to walk you through what it was like to create the video. So in the Quicktime Player, it's not launched, awesome. So in Quicktime Player, after you've plugged in your phone, you press File, New Movie Recording, and what you'll see is actual video screen from my phone. So if I go ahead and let's make sure this is muted. Excuse me. Oh, it doesn't even matter actually. So I'm going to go ahead and unlock my phone and dive into the application. So if I start to move my phone from side to side, you'll start to see that the items move. And here we go, the application's running, and I'm able to leverage it and render things and so on. So I'm going to close this out because we don't need this anymore. And so in order to record the video, what I had to do was basically record it through QuickTime. And what you're able to see from that is the raw video that you see you see most of the user experience, in about 30 frames per second or so. The goal for React Native applications, or any good application, is to render things at about 60 frames per second. It is just one of those things that helps allow the animation to feel really smooth. And so what I did was I recorded one version of the video with it unoptimized, and then a version of the video with the application optimized. And then I used Final Cut Pro to layer them together. And on the screen here I actually have the project that I leveraged. And what you'll see as I start to scrub a little bit, you'll see the frames rendering. Okay, so this is awesome because it allows you to kind of see what's going on. And from the application's perspective, if I zoom in, okay, so we go frame by frame. If you key your eyes in around the, let's see if I can get this situated perfectly. If you key your eyes in, you'll see that most of the images here are not showing up. So we have to continue. Let's zoom out a little bit. That's a little too aggressive. But if I go a few frames in, like here, 2 images have visibly rendered, whereas most of these images on the right have rendered, right? So if I go back, the next frame, and the next frame, and the next frame, so you start to see the progression of, where some of the bottlenecks are. And in this way, I could actually record the interactions that I was seeing, and I could actually demonstrate that, hey, look, the techniques I leveraged actually are somewhat more efficient than I guess using things out of the box. So let's go ahead and just dive in real quick and see how I did this. Okay, so I'm using a combination of, let's see if I can get this a little bigger. I'm using a combination of the navigation component. Actually, that's correct. I'm actually using 2 instances of navigation component. So when I press this button, what renders is another navigation component. So we basically see that when the view for the list is slid in, let me see if I can pull this out. Okay, so we're actually leveraging one navigation component, and then we're layering another one on top, and that gives me an opportunity to have a few different workflows, and this view can be consistent without items kind of pancaking on top of each other. So in this version, the application is quote-unquote unoptimized. So if I go back, and actually it would actually be a good idea to do this with QuickTime, give you an opportunity to see what's going on. Okay, let's do file, new movie. Come on. It's probably going to choose a camera. Oh no, fantastic. And there are my emails. Hooray for privacy! Okay, so in order to view this, I need to actually tell the simulator to package it and run it on my phone. So bear with us as this happens. Let's move packager out of the way. I don't need him. It'll get there eventually. Yeah, consequently, the slowest part of this entire process is a script that runs to actually package all of your items for iOS and shove it into the application bundle. This was a fantastic ad by I don't know if it was the Facebook community or the Facebook team, but this basically pulled us out of having to deal with originally a curl request and then React Native bundle method, which was a pain in the ass to remember to do. And of course, my phone is locked, so let me go ahead and unlock my phone and attempt this again and wait for this awesome shell script to run. It's going to take a while, I'm sorry. Okay, so the application is launched, okay? And when I press this, you can see very quickly that, oh boy, it is slow. And consequently, what happens, what I notice is the first time you try to do this, it's the slowest. Every time thereafter, it's generally a little faster. Have not really timed it, but it's a perceived feeling. So let's go back and change things up a little bit, and I'll explain how this works. So in order for the view to actually render, as you should already know if you have experience with, with list views, you have to take data that you have inbound, and especially for ones that have sections, you have to pull the data, pull it apart, create data blob, row IDs, section IDs, right? And in the pattern that is currently promoted, all the data is present as soon as the view is demanded into existence. So I copied a example from the Hello World, or the UI toolkit. I forgot, UI Explorer example, and the list view sections area had an example where you grab all the items and it basically generated some shit randomly and it just shoved it in. And what happens in this specific application instance is that when the views the data is being rendered and the initial items are being demanded into the actual UI, they're being rendered, the images are being requested all at the same time. And that's what nets you a much slower interaction model. So if I press this, this is part of why this thing is so goddamn slow. Okay? I asked this view to render, and oh god, it takes a long time. And again, if we were to go back to the version with Final Cut Pro, which I quit like an idiot. Oh, never mind, I minimized it, apologies. If you look on the left here, you'll see that when I slowed things down quite a bit, that the images are kind of popping in, and that's what slows things down. So the question is, how do I actually make this faster? And using documentation from the React Native, what do they call it? Interaction Manager. There we go. So if you were to read up on Interaction Manager, there's an example that basically says when the view first loads, you render a dummy view, and then afterwards, after the Interaction Manager has completed its actions, then you render the rest of the view. And I took that and I said, oh shit, I can leverage this pattern to the list view. And if I uncomment out my code, and excuse me with this console, if I go back and just kind of put things back in place the way they were, and this guy, 10. Okay, so when the getInitialState method is called, it's going to ask or execute the getNewState method, which takes the passes in this.props.data, which is the data blob that needs to get pulled out for the rows, the sections, rows IDs and section IDs and so on. But I'm passing in what I'm calling a limit. This is just something arbitrarily that I decided to do. And in here, in the getNewState function, we'll scroll down to them real quick. When I start to loop through the data, because this data structure is a little funky, I have to do loops within loops. Basically, I'm taking a total. Okay, so for every row item that I'm rendering or capturing from my initial data blob, I have a counter. And if the counter is defined and the counter is, or total, is greater or equal to the limit, then we basically finish the operation and we shove the data back into the view. So what I'm saying is, in this pattern, initially when the app renders, it only injects 10 data items. That's it. No matter what you do with list view, as far as try to say, I want to only render 10 items initially, because list view allows you to do that, I'm saying I don't want to have to deal with the list view stuff right now. I just want only 10 items to exist in the data set and render 10 items right away. That's it. So the big question is, okay, well, the view renders with 10 items. What happens afterwards? And this is where this Interaction Manager stuff really comes into play. So basically what happens is, when the component didMount method executes, the Interaction Manager.run after interactions method is function is executed, and then I'm passing in an anonymously bound function. And basically what occurs, it's really simple. I am just saying, okay, instead of just executing initially getNewState with a limit of 10, I'm just executing getNewState, which means that limit is by default undefined. And that gives me the ability to just run through all the data. So in short, the way this optimized pattern works is very simple. When the view is rendered initially, it only renders 10 items. When the Interaction Manager finishes, that is, the animation completes, then it goes through and updates the rest of the records in the data set. Basically, it just refreshes the view with the data set. And it turns out that just doing this very simple change netted me an extremely fast UI component comparatively, or compared to any other type of optimizations I would try with list view. Because if I were to just initialize list view with all the data items, which by the way, there's quite a few. If I were to just do that, then what happens is that I still have that loop of loops has to continue executing no matter what, even if the list view is only going to execute or render only 10 items. In this way, I'm just stopping everything short and I'm saying render only 10 items, get everything out of the data blob, only 10 items, and then inject only 10 items into the list view. So that's all it has to be worried about initially when the application renders. So when you see that animation complete, when this animation actually completes, let me turn this off. When animation actually completes, Interaction Manager runs that, where are you? Excuse me. Interaction Manager runs this runs my anonymously bound function, and then it basically refreshes my view automatically. And it turns out that by the time it takes, in my mind, to register the animation has completed and the list view is actually available for me to manipulate, the UI had done what it needed to do to render the rest of the items and make it absolutely usable. So what I'm going to do is demonstrate that. So let's go back to QuickTime, and I'll show you really quickly the unoptimized version. Okay, remember it is choppy. And I can scroll through the list, right? So it's choppy, but I can still scroll. Now let's look at the optimized version. Okay, so make sure I save this, go back to Xcode, and tell it to rerun my application. So we should be able to see this guy and Xcode. It's running that packager shell script again. Come on, man, faster! It's the best English accent I can muster. Which is pretty horrible, by the way, I understand. Okay, so this is the optimized version. Let's take a look. Quite a huge difference, in my opinion. Now, there is that initial jerk that is when you see the events by month text highlight and release, there is a little bit of a wait, and that's because the application is basically querying the database. That's when you see this little get all events sorted by date message being posted in the console. So it's basically querying for the data, but this is really damn good comparatively. And I'm not even trying to run this application with debug turned off. This is what I got really excited about. I was like, holy shit, this actually works very well in the space where I am running in debug mode. If you can optimize for debug mode, holy shit, your application in production should work really fast. And that's what gets me excited. So again, view renders, I can execute my scrolling right away. I don't even notice any type of issues when it comes to this application with this pattern. It just works. And I keep double tapping like an idiot because I'm trying to look at the screen and touch my phone at the same time. Okay, so let's look at this pattern in a different view. And I'll go ahead and comment out the optimization. So again, this whole concept of run after interactions is leveraged by the interaction manager on component did mount. So I'm going to go ahead and just comment out this block. Comment out this block just because, and we'll have to comment out get initial state as well. So the way this works is when the render placeholder only property is set to true, then we only render 5 items. So this basically is a scroll view that has an inner view that has a bunch of touchable components in it. Okay, so that's all it is. It's nothing magical. But the difference between the optimized version and the unoptimized version is quite stark in my opinion. So, oops, wrong view. Of course, that's going to be a small error on my side, so apologies. There we go. Okay, so we can even notice on the simulator some jerkiness going on when I tap, and I recognize that the simulator doesn't seem to be the fastest in the world for animations for iOS. I have no idea why. Like this view looks like shit in the simulator, but it works very well in iOS on the actual physical device. So I'm going ahead and run this on my actual physical device, and we'll give it a second to to execute. Okay, so it executed. Make sure my phone doesn't fall asleep. And what I'm going to do is render the GoRuck cadre. Let me see, can I move this good? I'm going to render the GoRuck cadre views. Boop. So we can see it's slow, relatively speaking. You can see some image flickering. Okay. Awesome. Now what I'm going to do is just undo my changes and get me to the point where my view is optimized. So let me go back, run, and while this is running, I'll show you what it looks like in Final Cut Pro, kind of in a frame-by-frame or play-by-play perspective. So we can see, even before the view on the left starts to render, on the right, everything is really smooth. And consequently, the pattern, again, between the two is very similar. That is, we only render what needs to be in view initially when the view opens up and comes into play, and then afterwards, when the interaction manager the run after interactions goes through its list of functions after the animation, everything comes in and renders full set. So tap it and bam. Major difference in my opinion in performance. And again, this stuff isn't magic. So if you want to figure out how this stuff works for your application, then I suggest you just simply go to the React Native's Interaction Manager documentation. I mean, the example makes a lot of sense if you, well, the documentation makes a lot of sense. Just read through it. It's not very long, and it'll make a huge difference in your application performance when it comes to demanding in views. And just to show you really quickly that I'm not smoking crack, if I go to the simulator and then go to, where is it? Quicktime Player. So on the left is on my phone, on the right is the actual simulator. If I were to tap event map, you see how slow and choppy that is. Oh, well, that wasn't very fast. I feel like an asshole. There we go. Yeah, first time in dev mode, it is pretty slow. But in the simulator, it is horrifically slow, relatively speaking. So awesome. This was fun, a lot longer than I expected, but I'm really hoping that you guys get to understand the pattern I used. Not very difficult to understand, in my opinion. Could use some tweaking, yes, but in the end, what I found is that it'll help me deliver really good experiences when I'm dealing with Navigator, Navigator iOS, and so on. So thank you very much for watching, and yeah, I hope to do this again soon. Take care.